Welcome back to the Deep Dive. It is Tuesday, February 3rd, 2026. Today, we are taking a look at Class 3 of the CS123 System Administration course. And I have to be honest, I was looking at the syllabus for today, and I had a real, wait, what year is this moment?
Let me guess. You saw the list of software.
I did. We're talking about Vi, awk, and bash scripting. I mean, these aren't just old tools. They're practically archaeological artifacts.
Oh, Vi is from the 70s.
It is. In a world of, AI-assisted coding and these slick drag-and-drop cloud dashboards, are we really spending a whole lecture on tools that predate Star Wars?
It does seem counterintuitive, doesn't it? Why use a hammer when you have a nail gun? But here's the reality of the job, and it's, I think, the first big mental shift you have to make to become a system administrator.
Okay.
You often don't get the luxury of a graphical interface.
You mean like no mouse, no windows, no menus?
Exactly. When you're managing a server farm or ezization into a remote instance halfway across the world, or even debugging a router, you are often just staring at a black screen with a blinking cursor. You have a text stream. That's it.
So it's about survival then?
It's more about universality. If you walk up to any Unix-like system on the planet, a massive supercomputer, a web server, a smart thermostat, whatever Vi is going to be there.
Right.
Awk is going to be there. Bash is almost certainly going to be there. They're the holy trinity of the Linux world. If you know these tools, you're at home on any machine. If you don't, well, you're helpless.
Okay, that definitely puts the stakes in perspective. It's the lowest common denominator toolkit. And the goal here, according to the notes, it revolves around this idea of staying DRY.
Don't repeat yourself.
Yeah.
It is the golden rule of admin work. If you have to do a task once, fine, do it by hand. If you have to do it twice, you should be thinking about how to automate it.
And these three tools, .vi, awk, and bash, they're the engine for that automation.
They are. They're the mechanisms by which we stop repeating ourselves.
So let's break down this trinity. We should probably start with the one that seems to scare people the most. The grandfather of text editors.
The FES.
The visual editor.
Which is such an ironic name, isn't it? Because to a modern user, there is absolutely nothing visual about a terminal window with no buttons.
Well, you have to look at the history to get the name. I mean, before Vi, there was X, which was a line editor.
A line editor.
You edited text one line at a time, completely blind. You couldn't see the surrounding context unless you specifically told the computer to print it out for you. So when Vi came along and let you see a whole screen of text at once, that was the visual revolution.
Okay, relative to the 70s, I get it. But for someone opening it today, the immediate feeling is usually just panic. You start typing, nothing happens, or worse, things get deleted, and then the whole system just starts beeping at you.
And that is the modal hurdle. This is probably the single most important concept you have to grasp about Vi. Most editors today, they're modless, right? Like Notepad. You open it, you type A, the letter A appears. Simple.
Exactly. Vi is different. It starts you in command mode.
And this is where the philosophy just completely flips. In command mode, the keys on your keyboard, they're not letters anymore. They're like buttons that trigger functions.
Precisely. Think of it like a video game controller. When you press D in Vi's command mode, you're not typing the letter D, you're issuing a delete instruction. If you actually want right words, you have to explicitly switch gears.
Into insert mode.
Into insert mode.
Which you do with I for insert or A for append. And then, okay, so you're done typing. How do you get back to safety?
The escape key. Escape is your home base. If you are ever lost or unsure what's happening in Vi, just hit escape until the system beeps. Then you know for sure you are back in command mode, ready to issue orders again.
Let's talk about navigation, because this is another huge point of friction for beginners. I mean, we have arrow keys, we have a mouse. Why does Vi insist on using H, J, K, and L to move the cursor around?
It seems perverse at first, I know. H is left, L is right, J is down, K is up. But look at your keyboard. Where are those keys?
They're right under my right hand, on the home row.
Precisely. The design philosophy of V is that your hands should never have to leave the home row. Every time you move your hand to the arrow keys or, God forbid, reach for a mouse, you're losing microseconds and breaking your flow.
So it's all about ergonomics and speed.
It's about maintaining a flow state. Once you build that muscle memory, navigating with HKL is so much faster than using a mouse. You fly through the file.
Now, the notes mention that V isn't just about moving and typing. It's almost like a language. This part I found really fascinating. Can you explain that?
This is the real aha moment for V users. Don't think of it as memorizing a bunch of shortcuts like Control-C or Control-V. Think of it as a grammar. You have verbs and you have nouns.
Verbs and nouns. Okay, break that down for me.
So take the verb delete, which is the key D. And then take a noun or a text object, like a word, which is W. If you type DW, you're telling the editor, delete word.
Okay, that's logical.
Now you can add a number to DW bell, delete 2 words. Or you change the verb. C is for change. So CDW is change word. It deletes the current word and immediately puts you in insert mode so you can type the new one.
I see.
Once you learn that vocabulary, you can compose whole sentences. DW means delete to the end of the line.
That is actually much more powerful than just highlighting with a mouse and hitting backspace. It's so precise.
It is surgically precise. And you can do this for huge chunks of text. 10DDD deletes 10 lines instantly. Y yanks or copies a line. PP pastes it. You aren't just, scrubbing through text. You are manipulating the structure of the file using a language.
And what about the ghost of that old editor, X? I see references to X mode in the notes, something about using a colon.
Right. So Vi is technically just a visual interface running on top of that old X editor. You can still talk to that underlying engine by typing a colon.
And that moves the cursor to the bottom of the screen.
Yeah, and that's where you do your file level operations.
It's like saving and quitting, right?
Yeah, correct. .w to write the file to disk.q to quit. And the one every student memorizes on day 1,
The panic button.
the panic button. Quit without saving, absolutely essential for when you've accidentally deleted half your config file and you just want to bail.
The notes also talk about search and replace in this mode.
Nice.
And the syntax looks a bit cryptic. %sold noog.
It looks cryptic, but it's pure syntax, and it's consistent. S stands for substitute. Then you have the pattern you want to find, then what you want to replace it with. The G at the end stands for global, which just means do this every time you see it on the line, not just the first occurrence.
Man, the present at the beginning.
Do this to the whole file.
So I wanted to change the word user to admin across a 1,000-line configuration file. I don't need to scroll and click. I just type that one line.
Exactly. Proteal % user admin G. Hit enter. It's done. Instantaneous. And, that really brings us to the limit of Vi. It's fantastic for interactive editing. But what if you have a million lines of logs? You can't open that in a text editor to look for patterns.
Did crack the system?
Right. You need to process it programmatically.
Which segues perfectly to the second member of our trinity.
Awk.
Digital scalpel.
First off, that name, awk. It sounds like the noise you make when you trip over a cable in the server room.
It does. But it's actually just the initials of its creators. Alfred Aho, Peter Weinberger, and Brian Kernighan. I mean, these are titans of computer science from Bell Labs.
So awk isn't an editor. The notes call it an interpreted scripting language.
Yeah.
But how is that different from, say, Python? Why wouldn't I just use Python to process a file?
And you certainly could, but awk has a very specific paradigm that makes it way faster for simple text tasks. Awk is data-driven. It assumes by default that you are feeding it a stream of text, line by line.
Okay.
You don't have to write a loop to read a file. The loop is implicit.
Wait, explain that. The loop is implicit.
If you write a Python script to process a text file, you have to write all this code that says, open the file, read a line for each line in the file, do X.
Right. In awk, you just say do X. Awk automatically handles the opening, the reading, the looping through every line, and the closing. It saves you all that boilerplate code.
That is efficient. And it views the text differently, doesn't it? It talks about records and fields.
Exactly. In the awk worldview, a line of text isn't just a string of characters. It's a record. And that record is made up of fields, which are separated by something, usually a space or a comma.
So it automatically chops up the line for you.
Yes. And it assigns each piece to a variable. $1 is the first word, $2 is the second, $0 is the whole line.
So if I have a list of, names and phone numbers, and I just want the names.
You just tell awk, print $1. That's it. It will run that little command on every single line of the file, printing out just the first column. No parsing libraries, no complex string splitting. It just works.
That's incredibly fast for quick data extraction. The notes also mention internal variables, NR and NF.
Those are built in. NR is number of records, which is basically the current line number. And NF is number of fields. How many columns are in the specific line you're looking at?
And you can use these for logic.
For logic, yeah. Like, only print the line if it has more than 3 columns.
How would you write that?
You'd write NF3, print $0 right now. And this brings us to the structure of an awk program. It's just a series of patterns and actions. Pattern. If the pattern matches, like NR1, to skip a header row, it executes the action in the curly braces.
And there are those special blocks, begin and end, right?
Yes. The begin block happens before the very first line is even read. It's great for, initializing variables or printing a title for your report. And the ND block happens after the very last line. Perfect for printing a total sum or an average.
There's a really good example in the notes using the etceterapassGUID file. We should break that down because it ties it all back to system admin work.
Right, so etceterapassGUID is the database of all users on a Linux system. It's a text file, but the fields aren't separated by spaces. They're separated by colons.
So awk's default behavior won't work on it?
Not by default, no. But you can easily change the field separator. You just use the flag F. So now awk knows to split the line at every colon.
And the one-liner in the notes basically says?
It says, using a colon as a separator, print the first column, which is the username, and the fifth column, the user's real name.
And that transforms this dense, unreadable system file into a clean, simple report of username, real name in just one line of code.
Precisely. And because it's a standard tool, you can put that command in a script and know it's going to work on pretty much any machine you encounter.
Okay, so vi lets us edit files. Awk lets us process data streams. But to really stay DRY, we need to glue these things together into a repeatable workflow. And that brings us to part 3, shell scripting with bash.
This is where the magic really happens. A shell script is, it's essentially just a text file that contains the commands you would normally type manually into the terminal.
So instead of typing them every morning, you put them in a file, make it executable, and just run it.
You run it. That's automation.
Let's look at the anatomy of a script then. It always starts with this shebang. Hashtags.
This is actually a message to the operating system's kernel. When you try to run a text file, the kernel looks at the first 2 bytes. If they are hashtag and s, it then looks at the rest of that line to find the interpreter program.
So hashtag bin bash is just telling the kernel, hey, I don't know how to run this text, but the program over at bin bash does. Give it to him.
It's the handoff, exactly. And then good practice dictates we should comment our code.
Always. You might think you'll remember what that super complex script command does, but I promise, 2 months from now, you won't. Use the hashtag symbol to write notes to your future self.
Please, it's so important.
Now, variables in bash seem a little fragile compared to other languages. The notes explicitly warn about spaces.
Oh, bash is notoriously picky about white space in assignments. In Python or JavaScript, X+5 is perfectly fine. In bash, if you put a space after the variable name, it breaks. It has to be variable value, no spaces at all.
Why is that? Seems so petty.
It's because of how the shell parses commands. In a shell, a space's job is to separate a command from its arguments. So if you type dirname report, bash thinks you're trying to run a program called dirname with 2 arguments and report. It gets confused.
Got it. So syntax precision is key.
Yep.
And what about this backtick trick? I see the date command wrapped in backticks in the example script.
That's command substitution. It's how you get data out of a command and into a variable. If you wrap date in backticks, or the more modern date, bash runs the date command first, grabs its text output, and then plops that text right there into your code.
So file name report date.txt would create a dynamic file name based on the exact moment the script ran.
Exactly, which is crucial for logs and backups so you don't overwrite your previous work.
Okay, but a script needs logic. It needs to make decisions. That means the if statement. But again, the syntax looks a little weird. What's with the square brackets?
The square brackets are actually a command. They're a shorthand for the test command. And inside them, you use these little flags to check reality.
Reality checks. I like that. Like DAPT.
Tet checks, is this a directory? Det checks, is this a file? IQ checks, are these 2 numbers equal?
And why is this so important for a sysadmin? Why not just, run the command and hope for the best?
Defensive coding. This is a huge theme in the course notes. Imagine you write a script that's supposed to go into a directory and delete old log files. So you write cd meteor rrrmm. What happens if that minder variable is empty or the directory doesn't exist?
The cd command fails, you stay in your current folder, and then rm runs in your current folder. And you might have just accidentally wiped your entire home directory.
Huh.
Or worse.
That is terrifying.
That is why you wrap it in an if. You write if d my dear, then. You verify that the world is how you expect it to be before you take a destructive action.
The script from the class notes pulls all of this together. It grabs users from etceterapasswad, it loops through them, it checks if they have a real login shell, and then it generates a report. It's a perfect example of the glue concept. It uses grep to filter, awk to extract just the data it needs, and a for loop to iterate over the results.
The loop syntax is for user in yearlist. Done.
Right, and inside that loop, it's categorizing the users, it checks to see Is there a signed shell bin bash? Or is it spinologen?
What exactly is spinologen?
It's a polite way for the system to say, go away. System accounts, like the user that runs the web server or the mail service, they need to exist to own files, but no human should ever be able to log in as them. So if you try, the system just runs spinologen as your shell, which prints a message and immediately kicks you out.
So the script is counting the real humans versus the system robots and then writing a summary.
And it keeps a running tally using Count++. By the end, you have a time-stamped file, formatted correctly, with meaningful data, all triggered by running one single command. That is automation.
Which brings us to the part everyone is probably waiting for or maybe dreading, the homework. Lab 3.
Yes, Lab 3. It's due next Wednesday, February 11th at 1:10 p.m. Do not be late.
We have 3 distinct tasks here. Task 1 is a V treasure hunt.
This is a fun one. V is incredibly deep. So your job is to find some feature we haven't discussed, maybe split screens or macros or registers, and then just write a short post about it on the Spring discussion board.
Task 2 is awk practice, writing scripts to reformat, etc., files into CSV or JSON.
This is all about parsing. Can you take raw system data and turn it into a structured format that another program could easily read? It's a very common real-world task.
And task 3, this is the big one, the bash script. And the prompt is really interesting. Translate permissions into English.
This is a great little logic puzzle. You know how permissions in Linux look like RWXRX?
A string of letters and dashes. It looks like total gibberish to a normal person.
Your script needs to look at that string and print out a nice human-readable sentence. Something like, owner can read, write, and execute. Group can read and execute. World has no access.
That sounds like it requires breaking down the string character by character and using a lot of if statements to map the letters to words.
Exactly. It forces you to use a tool like cut or awk to isolate the characters and then conditionals to translate them. And remember the instructor's warning in the notes, handle your errors.
Check your return codes.
Right. If your script tries to read a file that isn't there, it shouldn't just crash or print nonsense. It should say, error, file not found, make it robust.
So looking back at this holy trinity, we have the editor, the processor, awk, and the orchestrator, bash. It really does feel like a complete ecosystem.
It is, and it's an ecosystem that gives you an immense amount of power. But I want to leave you with maybe a word of caution about that power.
The dark side of automation.
Something like that. There's a famous chart, I think it's from an XKCD comic about automation. It plots time spent writing the script versus time saved by the script.
Oh, I know that one.
Yeah.
Where you end up spending 4 hours automating a task that only takes 30 seconds to do by hand.
Exactly. Automation is seductive. You learn bash and you suddenly want to script everything. But you have to ask yourself, is this script really worth the maintenance? If you only do a task once a year, just open up Vi and do it. Don't over-engineer a brittle script that you'll forget how to use by next year anyway.
That's the paradox. Just because you can script something doesn't always mean you should.
Wisdom lies in knowing the difference. But for this week, script everything, because it's for a grade.
Good advice. A deep dive into the terminal for everyone. Good luck with Lab 3.
Happy scripting!